Hmm. Okay, I think the clock is officially 15 past, so let's get going. Let's see if the clicker works. It does not. What about now? It did. Okay. Well, before we get started, let me introduce myself. My name is Egil Hansen. I'm a developer working for a company called Delegate, a Danish company. I live in Iceland, and now we're in Sweden, so it's almost like we got the entire, old Danish colleagues covered here today. I don't want to get in trouble with the Swedes here. No, I'm a Microsoft MVP, and I became an MVP because I built a bunch of open source libraries. Some of them we're going to talk about today. So yeah, that's an option for you as well if you want to join the MVP ranks, do open source. Now, this talk is about Blazor-testing, and so by the end of the talk, you should have a good understanding of some of the options that are available to you if you're building Blazor applications or building Blazor component libraries. But it's not going to be a silver bullet that you can go home and say, I'm always going to do that. I want to cover the various pros and cons that are with the different approaches you can take, and also give you the tools to decide, not just for Blazor testing, but in general, what kind of approaches you can take for testing your software. So what we really want to focus on what it means to write valuable tests that actually adds value to your solution, because it's not just enough that we create tests just for testing sakes. We want there's efforts involved with creating tests, right? They cost time and energy to create and maintain. So we don't want to just create tests for testing sakes and make the CI pipeline gods happy. We want to actually do the thing that gives us the most bang for the buck. And that's really what I want to focus on here in the beginning of the talk, and then we'll look at the different options that I find compelling, and then look where they might apply. Now, I want you to take a few seconds just to think about what are actually the properties that we like about, what are properties about valuable tests. And it doesn't have to be Blazor specific, but just in general, what is the properties that you would think to aim for when you write your tests? Now, for me, I can essentially sort of boil it down to 4 general high-level properties, things I want to aim for. The first one is protection against regressions. So the level of protection against regression you get from your test suite is proportional to the amount of code that's covered by the test suite. So a regression is when you make an inadvertent change to your production code and you want the test to break. If you didn't intend for that change to actually happen, you want the test to tell you, hey, you made a mistake over here, you probably want to fix that. Right. That is sort of one of the main things we want from our test suite. That's why we built the test suite, so we can run them and verify we didn't break things we didn't intend to break. Now, you could go for 100% code coverage. That's not really the aim for me. But you want to make sure that you are deliberate about covering the parts of the application that are critical, right? And certainly if you go for maybe a testing approach, again, that is some testing approaches will lead you to get more coverage almost by itself. Like for example, end-to-end testing. If you do end-to-end testing, you're going to touch most of the code base when you're doing that. You're going to touch your own code, you're going to touch maybe third-party dependencies, NuGet libraries, whatever you've imported, maybe even external services. So you have a very wide sort of scope in terms of protection against regressions. But there's also some downsides to going with end-to-end testing, as we will see later. So it's all a balancing act, finding what works best. The second thing would be resistance to refactoring. Now, that would be refactoring of production code. So you don't want to go and maybe change something that is an implementation detail, something that's not externally observable to the outside world about your production code, and have your test break. So a refactoring is changing something that isn't a business rule, a significant thing. It's like, renaming variables, stuff like that. You don't want to, or maybe restructuring your code. But if it's the internal parts of the code, the test ideally should not need to be changed and should not break, right? Because that's going to lead to you getting stuck. You can't move as fast as you want. You can't get the advantages, the benefits out of your test suite if it's constantly in your way trying to, make your production code pretty. Like a third thing would be fast feedback. So to get the advantages, to get the benefits of your test suite, you have to run it. And the faster you can run it, the more often you're likely to run it, right? So you're likely going to get even more benefit in a sense, right? So ideally, it should be part of your inner loop, right? It should be so that you can make a small change to your production code, then run all your tests and see if you haven't broken anything. If it takes half an hour to run your test, you're not going to run it every second, right? Or every 5 minutes. You're going to run it maybe once a day. That means that you're typically going to do a lot of changes to your production code before you run your tests. And anybody who tried to sort of go down maybe what's it called, like a refactoring rabbit hole where you start changing one thing and then the other thing, and then it's 2 hours later, and I probably not to go and run my test. I run my test, and half of them break. So, well, now you're going to spend another 2 hours debugging that thing. So in general, the smaller steps you can take, and that's sort of straight from Martin Fowler's refactoring book. Always take small steps if you can, because then it's only 2 minutes since the last time you ran all your tests and all the tests were green, which means that you only have 2 minutes of changes in your mind that you have to sort of look over, and then you can easily spot, well, where did I actually make a mistake? If you have half an hour or an hour's worth of production code changes, you're going to have to open up a debugger. And for anybody who tells you that test-driven development will help you go faster, that might be one of the examples they're thinking of, because you're forced, by doing test-driven development, you're forced into that very small step, quick loop, where you're constantly running your production code, constantly running your test, and that will save you from going into the debugger. So if you think about it, for me at least, whenever I have to set a breakpoint and start stepping through the code, that takes a long time. You're spending a lot of time inspecting variables, unpacking things, understanding what's going on. So usually that is where a lot of development time are wasted. So fast feedback is essential, and it's also essential that your tests are deterministic. Always do the same thing. Works on my machine doesn't really add value if it doesn't work on your colleague's machine. Well, because then the value is lost on him, and you've spent a lot of time creating tests that didn't bring that value it should. And finally, I think the fourth point here is maintainability. So we talked about being resistant to refactoring. That is resistance refactoring production code, but your own the test code should also be easy to maintain, which means they should be easy to change, because inadvertently you're going to change production code, or rather change externally observable behavior about the production code. So you want to be able to go and be able to modify your test code easily without sort of stopping you and having to do big refactors of your test code as well. So you want to be able to change that. You want to be able to understand what a test is doing. You don't want to come look at a test and say, well, I don't understand what this test is about. Then you can't understand why it is breaking, and then you can't fix it, right? So sort of these 4 properties are the ones I always sort of lean on when I want to look at various testing approaches, testing tools, and see, is this going to give me value in terms of the effort I have to put in? Now, I can do a whole talk just about these, but I will point you to this book. It's a really, really good book by Vladimir Korikov, where he talks about these principles and a whole lot of other things. So, highly recommend reading that. Now, that's sort of the theory aside. Let's talk about end-to-end testing in a Blazor, specific scenario. So, for end-to-end testing, I think I will sort of lean on Playwright, which is Microsoft's attempt at doing sort of that end-to-end test. It has a great developer experience, very strong focus on the resistance to refactoring based on all the lessons learned from previous libraries that came before it, like Selenium, where it certainly had a reputation of leading to unstable, indeterministic tests. So they're doing a lot of work there. They have things like automatic retry rating. They have the ability to generate visual traces of a test run, so you can actually go in and see after the fact, why did this fail? And you can understand it from a sort of a visual point of view, from a user's point of view. And they also have good documentation. I do want to highlight, though, that it is primarily, like the development of Playwright is focused on the JavaScript, TypeScript ecosystem. So the .NET parts of it might sometimes be a little bit behind in terms of feature comparability. So if you search online for how to do something with Playwright, you might stumble on the JavaScript documentation, and you want to make sure that it actually works also in .NET land. But for the most parts, it's sort of equal playfields there. Now, if you have access to the Telerik test suites, you can also look at this Telerik Test Studio. It's similar, and you get all the support from the Telerik folks as well. So I want to highlight that as well. Now, installation-wise, So when I started looking at that, and I'm an XUnit kind of a guy, so I went to the installation guide and started scrolling down, and I couldn't really find any XUnit in there. And it turns out there's a good reason for that. It has to do with how XUnit is very optimized for running tests concurrently in parallel. And there's some of the ways that Playwright wants us to structure our test that isn't necessarily compatible with that. It's definitely something you can do if you're an XUnit shop. But for this particular demo, I'm going to use NUnit, and it works excellently as well. Now, another thing we want to do right, we want to be able to spin up our Blazor web app in memory, so we are able to test that. So in the JavaScript part of Playwright, there's a test server, it's like a test HTTP server that comes with it that allows you to easily spin up whatever web app you're testing and access that, but that's not really part of the .NET experience. But luckily, in the .NET ecosystem, we already have something that does that for us, and that's the web application factory. I don't know how many of you have used that before. So for those who haven't, it's essentially a way to take ASP.NET web application and say, spin this up in memory and run that in isolation from everything else on the system while you're doing testing. So you would commonly see examples of using this together with, for example, testing your minimal APIs, stuff like that. Now, in a context with Playwright, where Playwright is a tool that will spin up a headless browser usually, but it'll basically load up a full Chromium or Firefox or whatever browser you want to test with. And that's sort of an out-of-process thing. So we need to do a few tweaks to the web application factory and make it work in this particular case. So in essence, it works like this. We have this ASP.NET Core web app or Blazor app. That is the thing we want to test. And we use a web application factory to spin that up. Now in our test code, inside the same process, so the big box sort of represents the process boundary of our test, we have a special HTTP client that we can use to access that application on the test. That's sort of the normal way you do it if you have a minimal API or something else that doesn't need a browser to test with. But because Playwright will actually instrument a real browser that needs to be able to connect to this guy, we can't just have it sort of hidden away inside a process. We actually have to expose it on an IP address. So we want it probably on something like 127.0.0.1 and on a random port that's available. So we are able to run multiple of these at the same time without them clashing with each other, right? We can't just have a fixed port. We say always use port 5000 or whatever. It has to be like a random port for every test that you're running. Otherwise, they're going to crash with each other. Now, that solves sort of the problem of getting Playwright up and running a specific app for test. So let's set up a demo. And I don't want to bore you with installing a lot of things. I've done it beforehand. So first, we need a Blazor application we can test. So we're just going to use standard .NET new Blazor app. So and this is going to be .NET for this demo, but this will work with previous versions as well if you're stuck on that. Now we need an NUnit test project. We do that like that. And then we need a solution to put everything into. And then we can just add the projects so that the projects are added to the solution. And we add a reference between the test project and the production code project, the Blazor application project like that. Now we need a few packages to help us. We need the Microsoft Playwright package, and we need this package, which is the one that have the web application factory inside it. That's the Microsoft ASP.NET Core MVC testing package. And to do snapshot testing, which I also promised I will tell you about, we need the Verify versions of Playwright and NUnit. So Verify is an excellent snapshot testing tool that supports all sorts of different scenarios. And these are the specific ones we need for Playwright. Finally, once we're done with that, we can build the whole thing. And when we've done that, Playwright will, during its sort of a compilation step, it will actually spit out a PowerShell file for us in our bin folder in the test library. And that one we run, and then it will make sure that the local environment we are on have all the sort of special versions of the browsers, the headless browsers that Playwright depends on. So instead of using your own, whatever browser you have installed on your machine, it will basically set up like special editions of the browsers that will work for testing, so you don't have to use the real browser you have installed on your machine. Now, with that, I think it's time to jump to Visual Studio. So let's see if I can make this work. I need to first pause the PowerPoint slides. There we go. And Yeah. Let me double check that font sizes are okay. So start in this test. Is the font size okay for you guys in the back? I see nodding. Good. Okay. So as I said, we need a few things, and to sort of help with setting up the web application factory, because we needed that with the custom ULs and stuff like that. I've created a wrapper around that called a Blazor application factory, and the program here it points to is the program.cs file in the Blazor production code application file. So that's sort of how it knows which web app to start up. And this type basically encapsulates the whole thing of actually configuring to expose the web app running on a port and so on and so forth. Now the next thing we need in our example here is we need Playwright set up, and that is what we're basically doing here. We are creating a new instance for Playwright. We are telling it we're going to use the Chromium browser. Playwright supports the most of the browsers available to us. And here we are setting up that we're basically pulling the base address of whatever was generated by our host app up here, our host component. So the idea is that we get a random port every time we start or run this Blazor application factory, which is the web application factory underneath. And since we don't know what the port is, we have to, pull it from the host like this. Another thing that's beneficial is to tell it to ignore HTTP errors. So especially if you're running on your CI pipeline, what can happen is that typically when we spin up a web application like this using web application factory, it's going to use the dev cert. And the dev cert might not be trusted on your CI pipeline because it's just your local, whatever, the .NET local dev cert. So this just tells Playwright to ignore if it gets any HTTP errors. Don't stop the world. Now the next part we need to do is, and that's basically this part, and this is equivalent to telling Playwright to open a new tab in the Chromium browser. So this is like hitting control, opening a new page, right? Now we get to the actually interesting bits here. And here we're telling Playwright page object we have from up here that go to this URL, and you can see that because we have that base address specified higher up in the code, we can just use relative URLs. So we're going to go to the counter page. And actually, why don't I just quickly show you what we are testing, so whether you know what we are looking at. So this is just the Hello World Blazor application that you get when you find a new project for Blazor. It has a welcome small extra component I've added that you can use for testing. We have the weather forecast app, or weather forecast page, that will asynchronously load a little bit of weather forecast data. So if you've worked with Blazor before, you've definitely seen this page. And then you have the counter component, and you can see that's located up here on the counter, which is the thing that we're trying to navigate to in our test. So to test the click me functionality in the test, this is essentially we want to go to this page, we want to click the button, and we want to see that the count increments when we do that. Now, so back in the test here, we go to the page, but I think this is a Blazor server application with pre-rendering enabled. So what happens is that when the first time you go to the page, and that would be the same for Playwright in this case, it'll go to the page, it'll get a pre-rendered version of the data down, but then we have to wait for the signal R connection to be established before clicking the button actually works. Normally for an end user, that's not a problem because that happens so fast, but because Playwright is an automated thing, it can actually start coming down to this particular bit here where we go and we find the button on the page that has the text click me, and we click it asynchronously. And if the signal R connection has been established at that point, nothing will happen and the test will fail. So what we're doing up here is we're telling Playwright to wait until the network is idle, which means that now everything has been established and there's no more communication going back and forth. Now it's sort of in an idle state. So we have to do a little bit of work in terms of making the test deterministic and be stable, right? Again, coming back to the resistance to refactoring and creating maintainable tests. Now, so as I alluded to, the next step is to go to the page and use the get by role to find the button on the page, and then trigger the async operation mimicking the user clicking on the button. Once we've done that, we can go back to the page and say, well, give me the paragraph element that has the ARIA role of status. And again, if we go and have a quick look here in the code, pages, counter, you will see that we have this element here that has the role of status. That's the one we want to find, so we can go and assert that the count didn't increment by 1. And once we have that, we have the code here. We can say, well, we expect the status to have text of current count 1. So that's sort of the hello world of Playwright testing. That's how we get started. Now, obviously, there's a bunch of things up here that doesn't really have anything to do with this particular test itself. So let's, again, make our test a bit more maintainable so we don't have to repeat that in all our tests. And that could look a bit like this. So what we have here is also sort of a concept from Playwright. They typically have something they call a page test. So I've created something that is a bit more specific to our need, called a Blazor page test, which encapsulates the Blazor web application or the web application factory and makes sure everything is up and running and spins up before it actually starts calling your test code and starts doing things there. It will also do a few things where, well, I don't need to start a new web application factory. I don't need to start a new browser Chromium instance every time for every test. I can reuse those between tests. So all of that is handled for us behind the scenes here, so we can focus on the essence of our tests and having sort of clean tests that focus on the business value. Another thing, which is a good trick you can do, is if you see things that you want to repeat in multiple tests, refactor them out into helper methods. So in this particular case, I've created a go-to rendered async method that encapsulates the whole thing of going to a page and waiting for that to be idle. So if you're doing, if the application you're testing is a Blazor server application, you want to have something like this in there, so you don't have to have all, the wait for idle and all of that in all your tests, right? So sort of the principles of creating simple maintainable tests where the language in the tests are sort of at a high level and you understand what's going on. Now, other than that, the test is the same as we had before, but I do want to touch on a few things that we didn't really cover before. The whole concept of saying get by role. Well, there's all those ways to go and interrogate the markup, the DOM that's being rendered in the browser. But the principle here is we want to look and sort of work with the content in the browser in the same way that the user would, right? And the user is looking for things like buttons, concepts like buttons, and we can lean on the ARIA roles, which is like for helpers that will help people that don't necessarily see a screen. They're using screen readers, but we can also leverage that. So you will know, for example, the counter component, the button itself has an implicit ARIA role of button, but having our test code set up such that we look for something that has the ARIA role of button means that I can go and change this to be an anchor or a div or something else, as long as I, in that case, explicitly add the ARIA role of type button to that, then my test will still run. So that again, that gives me that resistance to refactoring in my test code, that I can change implementation details in my production code. You can argue that in a Blazor application, web application, the type of element you're using to get some visual representation on the screen is probably more an implementation detail than it is something that you want to have hard-coded in your test, right? So things to be aware of there. Examples of things you want to lean on. Now, let's. I want to demo the tracing for you as well. So we have the same test here, but you can see here we have the ability to sort of set up a trace where it will track all the things it has in the browser, basically track the full browser state. So if your test fails, and this is a very simple example of a test. Usually Playwright tests or end-to-end tests tend to grow quite a bit larger because you will go through, maybe you have a complex UI, a complex wizard or something, and you're clicking through and you're clicking various places and doing a whole bunch of things. So it can end up being quite a long test, and having the ability to trace through all the steps and see how the UI changed along the way, that's really valuable. So essentially what you're doing is you're saying, at this point in the test, I want to start tracing. Then you do the thing, and then at some point you say, well, stop tracing and save the output into some place on this file system. And then you can use this command here, and I've already prepared that. Let me just put that up for you to open up the trace viewer. It's also really useful to do this on a CI pipeline if you're running something there. And the trace viewer looks a bit like this. Let me zoom in ever so slightly. So here on the left side, you can actually see each part of the test. So you can see we start by going to the page, then we click async, and it will highlight for you like where on the page, like where is the button physically getting clicked. And you can then also see, we go to the next step, we can see it highlights sort of with blue marker. This is the element that then changed when that happened. And so you can sort of, or you can scroll through the timeline. You can actually see the source code related to it here, C# code. Even though we are in a sort of a browser state, we can see all the network traffic, we can see the console output, we can see all the errors. So this is a really strong tool in terms of debugging if you have complex tests that have lots of logic going on. So that's definitely one of the advantages. And there's a similar tool that you can spin up, so to just basically spin up the application, and then you can click through the thing, so you can basically record a test and record what you're doing. We're not going to do that today. So next thing would be to have a quick look at the weather forecast page. So if we jump to the weather page over here, you can see this is using streaming rendering. And what it will do, and it is using a weather forecast repository to pull the data from some data source somewhere. So while that data is loading from the database, we start by sort of showing a loading screen, and then when the data is ready, it'll render out the data table, or the table with the content in it. Now, and you can see here, this is sort of the async place where we're waiting for data. So obviously we need again to make that test stable, because if we were talking to not just a fake database, but a real database, it might return in 5 milliseconds, it might take 2 seconds if it's running on a slow CI pipeline somewhere, right? So to make this test stable again, what we do, we go to the page, and then we can use this sort of selector here, which again says, wait for this, wait for a table with a T-body and some table rows, one or more, to show up before you continue. And then Playwright behind the scenes will start pulling the DOM every number of milliseconds and see, have the change come. And at some point, if it shows up, it'll let the test code run on. So that gives you that stability again, making the test predictable, stable. And then, again, the assertion down here is pretty straightforward. But so you can see here in this particular case, we just hardcode and say, I expect that to be 5 rows, because that's what we know is getting produced by our fake data thing. But in reality, if it's a real database, you might again want to have stable tests. You might not know exactly how many is going to return. So what you can do is you can decide, well, I'm not going to do complete end-to-end. I'm going to replace certain things. And so here's an example where, if you're again familiar with Web Application Factory, what it actually gives us the ability to is to hook into the services collection of the web app API of the Blazor web app we are booting up, and we can replace certain parts in there. So in this particular case, we have the weather forecast repository, but I'm just overriding that. I'm providing my own stop weather forecast repository. In this particular case, I'm able to, in the implementation I've done, is that I can specify how many weather forecasts you to return. So in this case, I'm saying return 1. And then the test now, again, we've sort of taken out that uncertainty in our test and replaced that with whatever we specify in our configuration. Okay, let me see. Let me just double check my notes so I don't skip anything. Yes. I do have a note up here about potential dragons in this. So what could that be, if you think about it a bit? So auto mode, the new Blazor Fangles render mode, where it starts out rendering on the server, and then it switches over the next time you go to that page and tries to use the Blazor WebAssembly instead of to run that page. This here, where I go and replace a service, that just works on the server, because that's what I have access to. I don't have access to replace the services in a Blazor WebAssembly application that's running on the client. So I actually do have that illustrated here in a demo. Let's see if we can get slides up and running again. So the example would be that we have this Blazor web app using server or render mode auto, right? And when the user first comes to the page, the API, the browser rather comes to the page. It'll go and render the weather page by going to the normal weather DB repository, access the database directly because we're on the server, and we can return things. But next time the user comes to the page, it'll be running in WebAssembly. So there's probably going to be some HTTP weather repository version that is not using the database directly because that's not accessible on the client, but the HTTP client version of that, which will then call the API that we have, which will then talk to the weather forecast database. So actually, in terms of testing, that's probably not going to be a big issue for you, as long as you are replacing whatever is accessing the database with something that's fake that you control on the server, because the client will still need to go from the browser, from the WASM to your domain where you have control when you're running the test. But I think this is a really good example, and it might be the first example in history where having the repository pattern in your code, and you can, if you have ever had a colleague say, no, you're never going to need to replace your database, right? You can actually say, well, I'm going to replace it in 2 seconds after you load the page second time, then it's going to replace live running in the machine. So this is sort of an interesting example of where we might have some dragons, as it were. Now, let's go back here and cover snapshot testing before we move on to the next bit. Now, snapshot testing is more about, in this particular case, where you want to go in and say, I'm just going to capture a snapshot of all the markup that this component of this page or this test rendered. And here we're using verify to do that. So verify, well, I could do a whole talk on verify alone. It's a super powerful library. But essentially, we are going to the counter page. Then we are awaiting and getting the content of the page, just the raw HTML. And we are passing that to verify and telling it to use the HTML extension. So what we have now, if we install the verify.playwright extension, is that it will actually do a semantic comparison. So if you change things that doesn't really matter to the markup, like remove white space, for example, it won't break the test. But anyway, when you run the test, you will see that it actually generates a verified file that basically captures the full thing. Now, it may be useful for you to do this. It's really going to depend on you, but there's also a lot of stuff in here that you might need to deal with. So it's an option to have. I don't lean on that too much, but it's definitely something to look at. And you can also have verify capture snapshots of the application that when it's running. But there's another caveat with that. If you're running on a CI pipeline, typically you will be using a Linux or Ubuntu-based runner. Well, the font rendering is actually not entirely the same on a Linux-based system versus a Mac or PC. So if it captures a snapshot when it's running locally in your machine, and you save that snapshot to the disk and say, this is how it's supposed to look, and then it runs up on the server, you might have a test that fails up on the server because the font rendering is not exactly the same. So that's definitely some things to be aware of there. Now, let's, yes? Yeah. Yes, so there's a whole bunch of different extensions to verify. One of them is the ability to basically compare two, JPEGs to each other and say, are these a close enough match to say that this is reasonable? And you can sort of turn the slider back and forth and say how close should they be. So that's what you can do. But you can run into things where fonts are slightly different on one OS than another, which is one edge case. But again, if you're using web fonts, it might not be a problem. But yeah, so that's definitely something there. Yeah. Mm-hmm. Yeah. So sure. So if you can, when you spin up the web application, it's essentially just running in a browser. So what you would then do, you might have, if all the pages are protected by password, so each test needs to basically go through a login type username password, then bouncing back and forth between Azure AD or something like a third-party OAuth provider and come back, and then you have the token, and then you continue. You probably want to have maybe a helper method that basically encapsulates all those steps so you can repeat them in all your tests. But essentially, you are writing test code that drives the browser by moving things around, and if it needs to go to a couple of different domains before it comes back to the web app you're building, then as long as you can do that from your local test machine, you can also do that using verify, right? So it should work, but it's definitely something, if you have common steps like that you need to do before every test, put that into a helper method, so if you need to fix that, you fix it one place and don't have thousands of tests breaking when you change the login flow, for example. Okay? I see nothing. Okay, I don't want to keep you over time, so I'm going to jump straight back to the slides. So let's summarize a bit here on... Come on, you can do it. Oh, we have done that already. Yes. So let's look at the scorecard in terms of the 4 sort of properties we had before. So definitely Playwright, you're gonna get high protection against regression because you're touching the whole thing, or at least down to the level where you decide to maybe stop out databases or third-party services. But you have the possibility here, and you're gonna be using the full thing. You're gonna be able to snapshot and see the CSS as well. All of that is gonna be included in your test. So it's gonna give you a supposedly high protection against regression. In terms of resistance to refactoring, probably also quite high, but then that is more on you in terms of writing your test in a way where you're not focusing on the wrong things in the test. Like, have the right scope in mind. Think about it from a user's perspective. Fast feedback, well, I'm gonna give it a low, but that's also relative. Like, Playwright test runs really fast, and in general, but it's maybe a low compared to, for example, unit test, right? Just regular old unit test. They're going to run much faster. Typical Playwright test will run in hundreds of milliseconds up to seconds for each test, and unit tests and component tests in Blazor terms will maybe run in single-digit milliseconds. So there's a difference there. And if you have many of them, it all adds up, right? Maintainability, well, in general, when we're talking about end-to-end testing, and that's not Blazor specific, it could also be API testing, there's more moving parts. Like, we talked about a full login flow right there, so there's more things to maintain, there's more complexity in there. You can certainly do a lot of legwork in terms of making it maintainable, sort of creating your own small helper libraries around that uses your domain language, so the tests themselves become easier, but that's more work. So it's sort of getting a medium if we have sort of a low, medium, high scale kind of a thing. Okay, so let's go to component/unit testing. I'm probably going to mix those up and go back and forth between component versus unit testing, but essentially we're isolating things and looking at individual components in isolation in Blazor terms. Now, for that we're going to leverage the library I've been building and been maintaining with a co-maintainer for 4 years now, I think. So that's bUnit. Now, what is bUnit? bUnit is a library for testing components, but basically being able to run the components in isolation and make sure that they are executed in the same way that the Blazor runtime will do it. So take them through the proper life cycles that Blazor components has and all of that stuff. It's render mode independent, so that's a new term we have in .NET 8, but it doesn't care about server, clients, auto mode or something. So it kind of is its own render mode, but it doesn't matter what is the target of the component that you are testing, where they're supposed to be running. It doesn't matter to bUnit. And it's designed very much so that it feels a bit like writing just regular unit tests. But you need a little bit of help. You can't just new up a Blazor component and test it like that. You have to sort of be able to capture the output from it and stuff like that. So, but it should make your test feel like a regular unit test. So all the patterns and practices that you have for writing unit tests in your own company, you can reapply them to bUnit test as well. And we include a bunch of sort of test doubles for some of the first-party services, most of the first-party services that come with Blazor. So the authentication bits, right? You don't want to do the full go to the some OAuth thing. You want to fake that out when you're testing in sort of a unit testing level. You don't want to lead. We have a fake navigation manager, and also we have a fake or a mock of the IJS runtime. So because bUnit is just running the test in memory in C#, there's no browser involved at all. So you don't get the benefit of actually testing sort of end-to-end your JavaScript that you might be depending on in your components. I do think the promise of Blazor isn't that we don't need a lot of JavaScript, so typically it's not a really problem. But you can definitely set up expectations saying this component, when this happens, it should be calling this JavaScript method, and you can verify that happens using the special purpose built mock for the IJS runtime. Now, that also means that bUnit test runs really fast and are much easier to make predictable and stable. So, this is sort of the superpower I think also bUnit gives us. Especially in the older days of Blazor, it was quite hard to sometimes debug a component, like setting a breakpoint and then loading it up in Blazor WASM and hoping that things hit, and it sort of was a hit and miss. With bUnit, you essentially just say, render this component, you can set a breakpoint in your Visual Studio or whatever editor you're using, and you just run your test and everything works. It's like debugging a unit test. It's super easy, and it's very convenient to get to that state. Now, let's see. In terms of pre-baking our demo setup, we essentially just need to add the bUnit packet and the bUnit version of verify. And we can add them to the same test project. Playwright, bUnit test, your regular unit test, all of that can coexist with no problem. Okay, so let's quickly go to the demo code again. And I need to stop the slides to have things realign. There we go. Okay, so let's close all those tabs and start by looking at the counter component again. So in this particular case, actually no. So one small detail, we generally want to, or it's generally recommended to write your bUnit test in Razor files, because then you get to leverage the Razor compiler and you get to basically express the component you want to test in Razor syntax. So to enable that in your test project, you need to basically change the SDK type to this, to microsoft.net.sdk.razor. That enables the Razor compiler to run in the test project, which means you can write Razor files in there and they will work. So once you have that, we can actually declare, the counter test.razor file, and essentially you just need to, because we're using an we need to add an attribute saying this is a test fixture, and otherwise we have a test set up like this. The first thing you will need in your Blazor test is a bUnit test context, and because NUnit already has a type called test context, in this particular case I've decided to just prefix it to make it explicit that this is the bUnit version of the test context. Once you have that, you get access to a render method that takes a render fragment. And this is sort of the magic of writing your test code in Razor files, is that you can actually just escape out of C# mode and go into markup mode and just write a render fragment directly in line and just say, this is the thing I want to test, here you have it. You can have anything in here as long as it's markup, essentially. And the output of that is basically our representation of the rendered Blazor component tree and the markup and all of that. And once we have that, we can use this find method here to go and say, find the button that we had on the counter page and click that. And once we've done that, we can then go and find the paragraph with the role of status and get its text content. And once we have that, we can do an assertion saying, well, that should now be equal to 1. So in terms of this test, there's not a lot of things that really isn't test specific, but this part we can certainly simplify a bit by simply just inheriting from the bUnit test context, and then the render method and a bunch of other methods available on the bUnit test context will be readily available in each of the methods, in each of the test methods. So you get a little bit of niceness. And if you have certain things that you want to always happen, like a pre-setup step, you can also move that in. You can create your own derived type from the bUnit test context and wrap that into your base type, so that you always have that done for you. In terms of the role-based lookup that I sort of highlighted in Playwright, we are actively working with Scott Sorber and another MVP that's working on getting the find by role methods to bUnit as well. So, for example, instead of having this slightly weird-looking syntax, you can do find by role, and hopefully, well, not rule, but role. Roll. There we go, roll. And then you would be able to just pass in status, right? So it makes it a bit more readable. So that is that's sort of that's an alpha version that's being worked on, and hopefully it'll be out soon. But you know how it is with open source. There's no guarantees. Let's undo this so I don't break the rest of stuff. Now, let me double check my notes here. Yeah. Okay, let's jump into the weather test. Now, in bUnit, as I said, we're not spinning up the full Blazor application, right? So we actually have to explicitly provide the weather forecast repository so that we can render our weather test weather page. So in this particular case, we have the services property that is coming from the bUnit test context. And here we're just adding a singleton for representing the weather forecast repository. And again, we're just reusing our stop weather forecast repository. So this is sort of an example of how you deal with that in bUnit, that you basically have to provide the service. You can't just use whatever production service you have already. Another thing I want to highlight is the wait for element. So again, because the Blazor component will have async code in there. And in this particular case, we know the stop weather forecast repository is going to return immediately, so I didn't actually have to have that wait for elements in there. I could just do find all and give me all the elements because they would return immediately. But in general, if you have any async code, timers or otherwise in your Blazor components and you want to write bUnit test for it, we have this notion of wait for elements or wait for assertion. There's a bunch of other wait for methods. And compared to Playwright, Playwright sort of is a pull-based model where it will keep pulling the DOM until the things we're waiting for show up. Because we have deep hooks into the Blazor render, it's sort of the opposite here. The Blazor render will wait for whatever async code that you own in your components are done doing its thing. And once it gets told to render the component, it will render the component, and then it will tell all the tests that are waiting for notifications, say, hey, well, I'm done. Go do your assertions, go check your things, and I'll block everything until you're done with that. And once you're done with that, I will re-render again until the component doesn't do anything. So that gives us, we don't have to pull every 5 milliseconds or 10 milliseconds. We just wait until something happens. So that gives us additional stability and more insights into what's going on there. Now, let me double check. Yes. Okay. So let's look at a slightly different example in this particular case. So for this demo, I also created the alert component that you probably, if you've ever worked with Bootstrap, you probably know the alert component. I can actually show it to you real quick here. So it's not uncommon that you have some sort of reusable components if you're building more complex Blazor applications or if you're building a component library. So in this particular case, we have this alert component. It has a few public, it has sort of just a public property that you can query to see if it's been dismissed. You can pass child content to it, and you can specify what kind of alert you want to have shown, and you can specify whether or not it's going to be dismissible. And then you have the markup down here. Now, to test that is sort of a place where bUnit in general gives you some more abilities than Playwright. So you're able to see, as you can see here, we can basically just define it as a render fragment and say, well, this is the parameters I want to pass. So it's clear, it's quite easy to understand what is being tested in this particular case. And in this particular case, we want to test that the alert gets dismissed and the dismissed properties then set correctly on the component when that happens. So we go and find the element, the aria close element, and we click that. And now we get the ability, because we are basically inside the Blazor render in a bUnit test, we can go in and look at the actual component tree, not just the markup that results that we see in the browser, but we can actually look at the raw component tree. So what we can do is we can go and say, well, go and find me the alert component in the component tree. And the tree is fairly shallow here. We just have a single leaf on that tree. But if you had a hierarchy, you can sort of drill it into the tree and figure out each individual component. And once we have that, we get a Blazor, a bUnit type out a rendered component, which sort of captures all the information we have about that component, the markup it's producing, all its child components, all of that stuff. And then we can go and say, well, give me the actual instance of that alert type, because Blazor components are just C# types, right? So we can just get that instance, and now we have an instance of the alert component, and now I can go and say, well, I want the dismissed property to be true at this point because we attempted to dismiss the thing. So you have that insight into your components. Now, obviously, this is again where you get into the territory. Is this an implementation detail that I have a public property on my component that is, that I'm looking at? Typically, you probably don't want to go in and look at properties on your components. If it's in an application, it might be an implementation detail. But if you're building a component library, it might be part of the public contract that you're promising the users of your component that this will be set. So in that case, you do want to go in and inspect the component tree. Now, another thing that might be really useful if you're building reusable components is to verify that the markup looks just so. So for example, in this particular case, we have the alert component, and if you go to Bootstrap, you see, well, this is the markup I'm supposed to be producing for the Bootstrap CSS to actually work, right? It expects a certain structure, certain elements, properties to be there for it to work correctly. Otherwise, it's gonna, not work. It's not gonna look the part when it's actually being shown to the user. So if the markup is not an implementation detail, I actually have a specific structure. But just doing a string comparison, saying, well, I got this markup and I'm expecting this markup, you can easily imagine that could lead to very unstable tests because you don't have to change a lot about the markup, like remove some white space or add white space or change the order of attributes before things break. And that would not be right because markup is quite lenient in terms of it will produce the same output to the user, like the rendered alert for the user will still look the same even if we change things about it. So bUnit comes with a semantic comparer that understands the differences where markup becomes different. So you can't, so you don't do a string assert equals, but you do markup matches instead. And that gives you a lot of information or a lot of possibilities. So if we go back here to the component, if you want to say, it's a bit hard to read when it's all cluttered together, so you can do changes like that, and the component will, the test will still pass because you haven't semantically changed the meaning of the component. You could also be that you have some sort of rule in your organization that all the role attributes should come last, so you go and refactor that and move it over here. The component, again, semantically is still the same. It's going to work and function the same for the end user. So we don't want the test to fail. And there's even more advanced stuff like, well, maybe we want the order of CSS attributes. That doesn't matter either. So there's a whole bunch of things you can change and refactor about the component with that shouldn't break the test. And that is sort of what you get when you have sort of semantic comparison in play instead of just, naive string comparison. So a third thing that you might want to do is, if you're building a component library, is that you want to test maybe all permutations of various combinations of input. And so instead of sort of having this inline snapshot of, if you will, you can also use verify. So here we have a data-driven test where we have a bunch of different combinations of parameters we want to pass to the component. So you do that like this, and then you just pass them in. And instead of having, 10 different versions of that test with just different content in the markup matches part, you can just say, well, verify, go and verify, or create a snapshot of this component on the test, the output from rendering that. And it'll also leverage the semantic comparer because I've hooked the semantic comparer capabilities into verify with the bUnit version of verify. And you can see here it produced some, 40 or so combinations, and you just have each of the expected outputs as small snapshot files. Now, let me double check. No, I think that was basically what I wanted to show here. So let's see if I can round out the last 2-3 minutes for you guys. Okay. Back to slides. And there we go. And the clicker works again. So let's look at a scorecard for the component testing approach. Now, protection against regressions. Well, I guess we have to give it a medium, right? Because we are not really high. We don't get to test the JavaScript parts as well. So that certainly lowers the spectrum. You can certainly write a whole bunch of unit tests that covers all the angles, but you're going to have to do a little bit more work. So it's not, in sort of comparison to end-to-end testing scenario we talked about before, that's not going to be the same level, right? Resistance to refactoring, I think so. Because again, that's more up to us as the developers. We don't get free ride from the tools we're using. You still have to use all the good practices that we learn, and we apply both to bUnit tests, but also our Blazor test in general, also to other kinds of tests you're writing. So again, we have the possibility of getting a high here if we're doing things right, similar to what we have with Playwright. Fast feedback, that's definitely a high compared to what Playwright is offering, because we can literally run 200, 300, maybe 1,000 tests while one Playwright test is completing. So this is sort of, these two are typically a bit at odds with each other, resistance to regressions and fast feedback. And maintainability, I think, so in general, if you're doing unit testing versus end-to-end testing, it's going to be easier to maintain unit tests. Again, if you're doing it with the right patterns, you're leaning on the right principles, because there's fewer moving parts, it's typically simpler to set up the expectations, the arrange step is typically simpler, less moving parts in unit and component test versus end-to-end test. But then again, that's also something that is very much a depend question. So, which one should you use? Yeah. Mm-hmm. That's true, yeah. So in my experience, you typically are more often redoing or fixing codes in your Playwright test because, as you say, I've changed something. But then again, that can depend on what you're doing, because if you're changing something that is visible to the user, then you probably have a test to fix anyway. But if it's something where, if you're refactoring properties of your components in a certain way in Visual Studio, for example, those refactorings might automatically flow down to your test, so you get that for free. But certainly, if you change something that is visible in the browser, then you might have a test to change anyway. But that's a good point, yeah. Now, I think it's very much a scenario-based choice here. There's no right one. Unfortunately, I can't give you a silver bullet and say, always do this, right? So if you're just building some Blazor app, maybe internal thing, forms over data, you probably want to start with end-to-end test, because there's not going to be a lot of value in writing individual tests for individual components, because you're likely not going to have a lot of reusability. You might have a whole bunch of pages, but if they're just basically pulling data from a database and serving it to the user, and there's maybe some wizards, some forms that user can click through, but it's all one-off things, probably end-to-end test is going to give you that value, give you sort of more value in terms of the effort you're spending. Now, complex apps, and if you have reusable components where you're using multiple places, if you have a larger team that is building that, then you're probably gonna want to leverage both, right? You wanna have, you could maybe use end-to-end testing to test the important happy path scenarios, like this is the killer feature of our app, this is what differentiates us from our competition, so we never want that to break. We want to have that as like a smoke test kind of thing. It should always be there. And then you can have maybe component tests for your more specific things, or if you have a sort of like the shared folder, if that is full of all sorts of things, you want to make sure that if you change something in there, that other teams that are doing other parts of the app, they don't have their stuff breaking if it shouldn't, right? So you can also have a component library with very little or just rudimentary JavaScript interrupts, where you just maybe calling down and you're using JavaScript libraries to do things, but you're just telling it, it's the interaction level there is more saying, well, I've rendered a component, go and hook in the JavaScript bits, but there's no complex interaction between the two. Then you will probably favor component testing, because that's going to give you a lot more value. And a lot of the component library out there, component vendors, both the paid for and the open source ones, are using bUnit heavily for this purpose, so that there you can go and test the component and all the various different combinations of parameters quite easily and get a lot of value out of that. Now, you can also be more a component library that's doing maybe quite a bit of interaction, or it's primarily just wrapping the JavaScript library. And there's also examples of that. And there the communication between the Blazor bits and the backend bits of the the JavaScript bits is super critical, right? So you might want to make sure that is the primary focus of the test, and there you can probably want to lean more towards end-to-end testing with bUnit tests sprinkled in where it makes sense. Like a good example of that would be actually the Blazor team itself. So what they're doing is they have the server component, the C# bits, that they both cover with unit tests, but then they also have a very complex JavaScript portion that will take the whole diff of the render tree whenever something happens in the C# bits and send that to the client, and then the complex JavaScript there will update the DOM. So they have a need for both, and they do a lot of end-to-end kind of testing. So I have all the resources you need here to have a look at. You can find all the demo code at this URL. Let me step out of the picture. And if you have any questions, come and ask them now, or if you want to ask them later on the socials, you can find me there. Yeah, I think that's it. Thank you very much, guys, for attending, and hope you have a good rest of the conference. And I'm sorry for stealing 3 minutes of your time.